Hi everyone, today in Integrated Math 2, we're going to go over Chapter 3, Lesson 4. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over a couple different things. Transformations for quadratic functions. When I say quadratic functions, remember I'm talking about parabolas. And if it's in the correct form, it is in the form of f of x, which is equal to a times x minus h squared plus k. H stands for the horizontal translation, which means it goes either left or right. K stands for the vertical translation, which means it either goes up or down. That's what K tells us. A is for the reflection, if it's going to open up or if it's going to open down. A stands for the dilation as well. And it's going to tell us if it's going to be really wide or really skinny. So, writing quadratic functions in vertex form. In vertex form, it is in the form of y is equal to a times x minus h squared plus k. And hk is the vertex on the parabola. X is also equal to h, which is the axis of symmetry, and a determines the shape of the parabola and the direction in which it opens. Alright, so now let's go ahead and try an example. We want to write the quadratic function y is equal to 3x squared plus 24x plus 15 in vertex form. Identify the vertex, axis of symmetry, and the dilation. And the direction of opening. So first, let's go ahead and write down our problem. Y is equal to 3x squared plus 24x plus 15. Over here, I'm going to write down the vertex form. So that was y is equal to a times x minus h squared plus k. And that's going to help us. So as you see here, first thing that we want to do is factor. So here we can see that we have a 3 in common with these two. We're going to leave the k by itself. So only factoring the a and the b part. So 3. We're going to leave both x's there because we're going to need them. I'm going to say x squared plus 8x, close it, plus 15. So now I have y is equal to 3 times x squared plus 8x, and here we're going to have plus blank, close your parentheses, plus 15 plus blank. But remember, I factored out a 3 from here, but I also did not move this 15 to the other side. So in this case, I still have whatever I do to one side, I have to do to the other side. But in this case, it's going to be the same side. So the opposite of 3 is negative 3, because it's still being done equally. Not necessarily to both sides like we've been used to, but it's being done equally. So now let's complete the square. So 8 divided by 2 squared. 8 divided by 2 squared. Alright, now we have y is equal to 3 times x squared plus 8x plus 8 divided by 2 is 4. 4 squared is 16 plus 15 plus negative 3 times 16. Now let's simplify this. So y is equal to 3 times, well, I know what this factors out to be. It factors out to be x plus 4, but that's going to be squared, plus, and this is going to simplify to be negative 33. Now let's see, is it in the correct form? We have our a, we have our x, h, we have our square, and our k is negative 33. So it's in the correct form. So our vertex, as you recall, was our h and our k. Our H is right here, and our K is right here. It has to be the opposite because there's a minus here. So -4 and -33. That is our vertex. Our axis of symmetry was that when x is equal to h, therefore our h is -4. And if you're still confused when I'm saying -4, I have 3 times x minus -4. And negative times a negative makes a positive. That's our squared plus -33. So now you can see the -4. And a is positive, so we know because of 3, so our graph is going to open up. And that's it.